Hello, my name is Gabriel Starczewski, and I'm a test engineer. Today I would like to talk about Jmeter. It's the second part of the course, Jmeter in 100 minutes. If you haven't seen the first video, then I invite you to watch it first before watching this one. For everybody else, this is a continuation of the part one. So, we are going to talk today about processors and samplers. So we'll see first elements of Jmeter when we can actually write code. Then we'll talk about test plan structure. It might seem weird that we are talking that in the middle of the course, but there is a reason for this. And we'll also cover some Jmeter elements, not all of them, but some that make your tests more realistic. And we'll talk about cache manager and embedded resources downloading to simulate better behavior of the browser. But there are more such elements, and we are not able to cover all of them, but that's why we have great Jmeter documentation, which you should always have at hand, or if you think about help for any particular element, and being here, you can always click in the help button and it will open the page specific for that element. Okay, what we are going to cover here in the detail, let's go back to our GitHub repository and let's move to processors and samplers. Okay, these are first programmable elements of Jmeter. So in here we will create a custom sampler using Java or Groovy languages. We'll also create a preprocessor to modify requested URL based on thread number. So let's get back to our plan. We'll try to do it without refreshing the Jmeter scenario. Well, we have our loop controller, and we can add here a sampler. But this time we will add JSR223 sampler, which allows us to write custom code. Well, we'll need to find a name for our sampler. We have here multi-get request, and therefore maybe we can do HTTP custom sampler get request for www.google.com, and we'll use the power of Groovy language, which is the default one, to issue the call to the URL that we store in the URL variable. You can have a look at your user-defined variables. This points to www.google.com, and this means for this string, so http www.google.com, make it to URL and then get text. This has an effect of fetching the contents of what is available at that URL. Okay, so let's do it. We have it. So we need to test it. I see our custom sample ran, and we can see that the response is correct. We basically get the same as for the HTTP request. Okay, so it's our first piece of code that we wrote. Basically, all the samplers, when you insert something that's a sampler, like JSR, you also have preprocessor, JSR 223, postprocessors, the same, you can code in that. And the default is the Groovy language, but if you want to, you can use UFI or the expression language here. You have some options, or even JavaScript. Now, we would like to a little bit modify our request, and based on let's say based on some variable, so for instance based on thread number, modify the URL. to another one. So first thing we'll do, we'll define alternative URL. Well, Google Pages are available in multiple languages, so we can use .es domain, which is the default Spanish domain. And now we can our multi-guide request, we can add preprocessor. Let's say we want to influence this one. So before it's fired, we'll be changing the request based on thread number, for instance. So how do we do it? So processor is something that will get executed before this one because it's a child. So we can call it pick domain, for instance. And then we just need to code the change in the variable. So we can use the following Groovy snippet where we are reading the thread number from the context of the Jmeter application. So in all the code elements where you can code, there's a context variable which allows you to access many useful objects from Jmeter context. So for instance, we can access things like thread number, loop iteration, thread iteration, and many more, or properties. Now, the important thing here is based on the thread number, which we got from the context, we are changing the URL to Google S, or we can change it to, well, alternative URL. In that case, we can simply do something like that. And that's it, and that should work. So now for every second one, we should have a call to another domain. So let's try it. Okay, so our multi-get request has been issued. And as you can see, it's for Google S. It's for Google S. It's for Google S. And it's for Google S. So all of them went for Google S. Therefore, we must have made some mistake in here. So let's see what the mistake is. So the thread number, how many thread numbers do we have? Well, we have just one. That's why we don't see the change. So let's change it to 2 and let's run it again. Now we expect that to be changed for every second one. Yeah, we can see that for this one, which performs 2, we have Google.com, and for the next one, we have Google S. Okay, so we just influence the request like parameters by using preprocessor, and this is how you can use it with the code. And here we have our own custom one. Okay, so now let's make exercises. Well, define alternative URL in a variable and modify preprocessor to modify URL picked based on loop iteration. So we've already done that actually, but we can do it once again. We can change it to a different domain. And the second part is let's make the choice based on the loop iteration. So this snippet already has the piece of code to detect which iteration it is. Therefore, the only thing we need to do is we can change it to this method call, and then we'll get this behavior, but based on the loop number or loop iteration. We have also 2 loops. And as you can see, we're starting with Google.com. And here we have Google D. Okay, and that's how we can solve this exercise. Now, let's just reset ourselves to the head. Let's do it hard. And let's refresh. And let's see how this was solved initially. It's very similar. this has not been done, so you can just copy paste it from here. Okay, thank you. And that was a very short part about processors and samplers, but basically the coding elements. So places where you can code. So if you are a Groovy lover or you like Java, then you can use your language in here. You can also use JavaScript, but Groovy is probably the recommended one right at the moment. Now let's move on to the next part. The next part is about the test plan structure. In this part, we'll look at setup threads group. We'll look at how we can do some custom stuff in samplers in the setup thread group. We'll also use tear down thread group to perform modification of log file. So in here, we have the main thread group, but there are also two other ones, which is the setup thread group, which usually is used if you want to do some setup stuff. There is also another one corresponding to it, which is tear down group. So if you have to do some activities that are related to cleaning up, for instance, then that's actually where you do it. So we have setup thread group, tear down thread group. Sometimes they are not necessary, but we'll try to perform some actions here. So let's assume that we want to create a custom log for our custom sampler. So the one that we coded in here. We can do it by using the sampler. So create log file. But we can also use this to define some properties. So I sometimes use it just to separate the function that they perform. So let's say I will here define the log file name, custom log, and in that sampler I will create the actual logger, well, log file. So in Groovy, you can achieve that with new file, and then you just process the log file name, and you can also write the header because you want to have a header, request, and time. So let's see whether we actually get it created and whether everything's fine. Okay, we can see that it has been executed successfully. Therefore, I should expect to have a custom log somewhere in my directory where the Jmeter bin is. Okay, I can see it in here. And this is how it looks like. I have a log file with request and time. All right, but that's not everything that I wanted to achieve. I want to extend that with some functionality. I would like to save the time of the execution of that sampler to my log file. For that, I need to store the start time. I can do it in milliseconds. And then I need to calculate from end time to total duration time. I can do it like that, and I can store this, append it to a file I want to append. I don't want to overwrite. So let's try to see whether it works. Well, it seems it works. I didn't get any error. So let's go to our custom log file and see whether I got what I wanted. Yeah, it seems it works. So I have saved the domain URL and the time in milliseconds. Great. So now in the tear down group, you usually do some closure activities like closing some custom database connections or removing some kind of temporary data. But what we would like to do, for instance, here, would like to use the tear down thread group, so something that's executed when all threads are done, to display our log file in the console here. So you can follow the same basically set of rules. And then we need to read it here, our log file, and display the results, which can batch shift within snippet. just read it, iterate, well, read all the lines and print results. Not very efficient, and obviously if you have lots of the calls, then maybe we need to rethink how we do it, but this is just the purpose of demonstration. So let's run it. It seems it works. We just need to wait for the display log to finish to see whether it's correct. Okay, it's correct. Let's see whether we got what we wanted. As you can see, we have a line here displaying our CSV file. That's why I'm saying if we have lots of time, we probably don't want to do it, but it's just the purpose of demonstration. And great. And now you find out how we can use setup threads and tear down thread group to do some activities before the main thread group starts and after the main thread group finishes. So you can use it to prepare and close properly your tests. Now let's go to the exercises. The exercise for this part is in the Tirna thread group transfer custom log to insert aggregate header at the end of the log. So for instance, we want to know how long all the requests took. We want to calculate. So if you want to do it yourself, then pause this video. But if you want to see the result, then bear with me. So the only thing we need to do, we need to change it to something that reads the lines and actually finds all that are not the header and creates, well, and calls a sum function on all of them for the element that contains the time. And in our case, that element was, well, it was the second one. So let's do it. We can observe whether all our requests finish fine. Well, there's an error, so let's have a look. Okay, there must be some typo. Let's have a look at that. Okay, I think the typo is in here. Let's run it again. And let's observe the result. Okay, it's a success. So let's have a look at our custom log file. Now it contains basically the sum of all the requests. So we've modified something that we created within main thread group in the closing activity. We just transform it. Okay, that's great. So we are ready to move forward. Now let's go to the cache manager and make it a more realistic part. But if you are interested into seeing how that was resolved originally, then you can reset this branch to head. Just remember to do it hard and then refresh in here. And you can see that the names of the samplers are different, but we still do the same thing. Okay, let's move to the next part. In this part, we'll talk about some elements that you can add to your test scenarios to make it more realistic. And we'll take an example of a cache manager and download embedded resources option. Why is that? Why are we talking about this? We're talking about this because when we make especially HTTP requests, then usually we want to simulate the browsers. And when the browser downloads something or processes some HTTP resource, which usually is probably the web page, then it does it in a certain fashion and some rules apply. Usually browsers have cache, and if there are some resources on the web page that can be stored locally, then browser does it and stores it in the local cache. So when the subsequent request is made, then the resources that can be fetched from local cache are fetched from local cached, and this speeds up the page load time. The same applies to downloading some of the resources in parallel. Usually when you go to the web page, like a google.com or Google PL, when you have a look at what's inside, then there are probably many embedded elements too. You can find out how many by looking at the network and see that there are some images here, and quite a lot of images actually, but also some icons, maybe some JavaScripts and HTML too. And some of these resources browsers download in parallel, so it doesn't have to be sequential. As you can see in here, some of them are downloading at the same time, and caching together with downloading in multiple threads embedded resources speed up the page load time. So our Jmeter call, let's just focus on HTTP request. It currently does not do it, and we are not using any cache. So we need to make sure that we simulate HTTP browser better, assuming that we want assuming that our case is just for that. You might probably not want to do it when you'll be testing just the API of an endpoint, but if it's a web page and you want to, for instance, generate or simulate user sessions, then you definitely want to do it. Okay, so how do you use Cache Manager? There is a config element called Cache Managers with some reasonable defaults. And the important thing here is that it can store up to a certain number of elements, and usually this is fine for most of the tests. You don't have to check it. Now, if you want to know how that will influence your performance, then you can do the following experiment. You can disable Cache Manager. Let's also disable, well, let's not disable it, but let's set it to, let's say, this loop controller to something larger, like 4. And when we run it without the cache manager on, then we can see what the aggregate times are. Well, and we probably are interested in median or their 90th percentile or so for the GET request for this one. Okay, test is finished. The value is around 200 milliseconds. But making this request so we are not yet downloading the embedded resources. So in order to see how Cache Manager really helps, we need to make sure that we are downloading all these embedded resources. So all the things that I showed you in my browser. We can skip parallel downloads for now, but you'll probably want to play with that too. But for the time being, let's just make sure that we retrieve all the embedded resources too. As you can see now, where we had an individual HTTP request before, we have now more of them. These are requests for PNG files, as you can see. This the main request for PNG file, and for some TAE, PNG, whatever that is. So we get more call because now we are downloading those embedded resources. And now, as you can see, multi-get request median time is around 540 seconds. So the question is, if you use the cache manager, so on subsequent calls, if you get some things from cache, would that be faster? Let's check. And let's go here. And let's see whether these values will change. You probably saw for a second that the first request was in the range of 600 milliseconds. That's because at the first time the browser or Jmeter will download all of them, and some of them will be stored in cache. But the subsequent ones run already much faster, and as you can see, the median is just around 200 milliseconds. So yes, Cache Manager has a huge impact on time of your request, HTTP request, if you want to simulate real browser. So use it. Okay, and that's it. We have learned how to make scenarios more realistic. If you want to simulate a real browser with HTTP Cache Manager and some options of the HTTP request defaults element. I invite you to also experiment with other options that are available here, especially parallel downloads. So now we can go and see what is the exercise for this part. Use HTTP request defaults and Cache Manager to see how will the number of requests change, as well as their time when they are enabled. Modify elements in cache to 2, has anything happened? And the second, run stress test setting threads and ramp up to some high values. Are you getting errors? Should Google handle it? Okay, so we just perform exercise number 1. If you want to do it yourself, then please pause and do it. Otherwise, bear with me. So we have performed an exercise where we had Cache Manager on and off, and we saw the difference. Now, what's going to happen if we change it to 2? The best is to have a look at this aggregate graph. And as you can see, well, the results are very close to the Cache Manager disabled, and that is because we just allow to store 2 objects. If we allow to store 10 objects, then probably the results should already be better. On a single page, there is a finite number of elements. Therefore, sometimes you want to play with the size of your cache, in order not to run into memory issues. As you can see right now, I'm already getting results like with 5,000 elements because I don't need that big cache right at the moment. The bigger cache, the more memory you need, but the smaller one can actually bias your test results. So use it wisely. And that's it for this part. Thank you for bearing with me. Just to sum up, we have went through some of the important topics when it comes to Jmeter performance tests. We talked through some basic elements where you can code your custom logic, the basic test plan structure using setup thread group, main thread group, and teardown thread group. Also some transformations of some custom elements that you can do at the end, and also how to use various elements to make your scenarios more realistic. But remember that we have lots of them, and the documentation is your friend in that journey. So that's it for the second part of the Jmeter in 100 minutes course. I invite you to see the third part, which will talk about extractors, running tests and reports, and also debugging. Thanks, and see you later.